All right, I hope you are doing well. I hope you're doing well. So I'm just going to give you a rerun of what we were talking about due to bad connection. We were disconnected, but I said we're going to look at the two types of series and progressions, the geometric and arithmetic. Okay, so the arithmetic. So for both of these, we're going to look at a series and a progression. Okay, then we're also going to look at a geometric. Okay, so for both of these cases, arithmetic will look at a series and a progression. Then for geometric, we're also going to look at a series and a progression. So all you have to do here is just know a few formulas, memorize a few formulas, and you'll be good to go, because these questions are a walkthrough in all tests. So what is the difference between a series and a progression? Very simple. A progression has numbers in a pattern separated by commas. So we see that there is a pattern of numbers here from 4 to 2 to 1 and so on and so forth. So this pattern continues. And when you see numbers separated by a comma there, you know that it is a progression. So either arithmetic or geometric. And I'm going to basically tell you how to know if that is an arithmetic progression or a geometric progression. Okay. Then a series. A series will have a pattern separated by addition or subtraction. So for instance, you can have 4 plus 2 plus 1 plus so on and so forth until we go to infinity. You know that this is a series because the numbers are separated by a plus. So it can also be 4 minus. So -4, -2, -1, and it goes on and on. It can also be an alternating, changes between positive and negative. So -4 plus 2, -1, and so on and so forth. So this is an example of a series. So a series will have plus or minus in between numbers. A progression will have commas between numbers. Okay, so now having that said, in this lesson, basically, we're going to look at a geometric progression, and we're going to learn how to find the nth term, so which we're calling the nth term. So for instance, here we've been asked to find the seventh term. So we've been given a pattern like this, and we're asked to find the seventh term. And we're also going to learn how to find the sum of the first nth term. So if you remember starting, I gave you this right here. Let me just clean it out. I gave you this right here. And when you check on under series here, you have geometric series, and you've been given this here. So you can write these formulas down. Okay, you can write these formulas down. So these formulas, you title them sums. Okay, so we use this formula to find the sum of a geometric progression. So the first one is when the value of r is less than 1. So when the value of r is less than 1, so we'll see, maybe it's like 0.1, 0.02, maybe -1, -2, and so on and so forth. So when the value of r is less than 1, we use this formula. When the value of r is greater than 1, so we're looking at 2, 3, 1 point something, 1.5, and so on and so forth, we use this formula here. We're going to look at what all these entail. Okay, then after copying these, we are going to also need to know how to find the nth term. So the nth term, so the formula for the nth term is given by Tn, meaning that nth term is equal to the first term of the series times r raised to the power n minus 1, okay, where a is equals to the first term, okay, first term. So for instance, in our series 4, 2, 1, and so on and so forth, in this sequence, we see that this is the first number, so the first term in this case is 4. Then R is the common ratio. R is the common ratio, and how you find the common ratio is the next term divided by the preceding term. Okay, so in this case, the next term is 2. So 2 divided by the preceding term, which is 4. Okay, so that is how you find R. So when you simplify this, you're going to get 1 over 2, because 2 can go there 1 and 2 can go there 2, so 1 over 2. Then n is the term that we are looking for. Okay, so the term that we're looking for. So in this case, we're looking for the seventh term according to the question that we have down here. Okay, so now let's see how we can approach this question here. So given, you can write this question, given the geometric progression 4, 2, 1, find the seventh term. So we know the formula for the nth term. So I hope you can rewind and copy that. And yeah, so we know the formula for the nth term, which is equals to the first term times r to the power n minus 1. So you can find the nth term using this. So now, in this case, the seventh term, so n is equals to 7. Okay, so what is a, the first term? So the first term in this case is 4. And r, we said to find r, it's the next term divided by the preceding term. So the next term, we can even pick here, it will be the same throughout. So the next term is 1. 1 divided by the preceding term of 1 is 2. Okay, so that is 1 over 2. Or we could use 2 and 4. So the next term is 2. So r will be 2. And the preceding term of 2 is 4. So 2 over 4, which will give us 1 over 2. So we see it's giving us the same answer. So we found our R, our A, and now we can find the seventh term. So T7 will be equal to the first term, which is 4 times R. We'll put R as 1 over 2 raised to the power 7 minus 1. Now here you have to start with this part that has a power. So you're going to have 4 times 1 over 2 raised to the power 6. And basically the power is applying to both the numerator and the denominator. So this would be 4 times 1 to the power 6 over 2 to the power 6. Okay, this simplifies to, let me write it here, equal to 4 times 1 to the power 6 is just 1 over 2 to the power 6, that's 64. So we see that when multiplying, we multiply 4 and whatever is on top there. So 4 times 1, it will be 4 over 64. We know that 4 can go into 64. So 4 into 4, that is 1. And 4 into 64, that goes there 16 times. So this will give us 1 over 16. So that will be the seventh term. If you're asked to find the eighth term, let's try for the eighth term now. Or let me say the 10th term. Find the same question. Okay, let me put it here. Find the 7th term and the 10th term. Okay, you can just copy that example. You can pause to try this one out by yourself. So we are using the same progression here. So T10 will be equals to the first term times R times n minus 1. So the first term in this one is 4 times R, which is 1 over 2. So the R will not change because it's the same series. Then to the power 10 minus 1. So it will be 10 minus 1. Then again, you go through the same process of simplifying and you're done. Okay. So now, since we know our R, which is equal to 1 over 2, we come to finding the sum of the first 9 terms. So this is our last question. Then I'll give you a question to try out. Okay, you can go back and take that. So find the sum of the first 9 terms. Okay, now when we go back to our formula here, let's take note of the value of r. So r is 1 over 2. So is 1 over 2 bigger than 1 or less than 1? So we see that 1 over 2 is less than 1. So in this case, our r is less than 1. Now, there are formulas here. So you know that for r that is less than 1, this is the formula that you use to find the sum of the nth term. Okay, so in this case, our r is less than 1. If our r was greater than 1, let's say 2 and so forth, we would use this formula. So since our r is less than 1, we use the formula for the sum as Sn is equal to a open brackets 1 minus r to the power n all over 1 minus r. Okay, a is still the first term, and here we are looking for the sum of the first 9 terms. So S9, so where there is n, we put 9, will be equal to the first term. In this case, it's not changing, it's still 4. So 4 open brackets 1 minus our r. We know what our r is, which is 1 over 2, 1 over 2 raised to the power n. We know n is the first 9 term, which is right here on, so raised to the power 9. We close the brackets over 1 minus r, which is 1 over 2. Okay, so we'll just simplify this and we'll have found the sum of the first 9 terms. So this will be equal to 4 open brackets 1 minus. So here the power is applying to both the 2 and the 1 and the 2. So 1 minus 1 to the power 9 over 2 to the power 9. Then down here we have 1 minus half, which is just half. Then we can simplify this as 4 times 1 minus, this will be 1 raised to the power any number is just 1 over 2 raised to the power 9. So let me see, just do it here. 2 raised to the power 9. That's 512. So we can put 512 here. Okay. 512 divided by 1 over 2, which can be written as, so the 4 here, we can find the common denominator. We can just do that. So right here, since we have 4 outside, we can say the common denominator is 512. So between 512 and 1 here, that's the common denominator, 512. 512, you say 1 into 512, that is 512. 512 times 1, that will give us 512. Then 512 into 512, that is 1. 1 times 1, that is negative 1. So there is a negative here. Okay. Then divide by 1 over 2. So there is divide by here, then 1 over 2. Okay. Then here we can simplify this. So this will be 4 open brackets 512 minus 1, that will give us 511 over 512. Okay, then here the division, we can change it to multiplication. If we change it to multiplication, these will swap, it will be 2 over 1. Okay, then we just multiply, so it will be 4 times 512, then times 2. Okay, so we can even write it as 2 times 4, so that is 8, then times 512, 511 over 512. Okay, so we'll just multiply the 8 with the 511 there. So times, so 511 times 8. That will give us 4088. over 512. And we are done. We can leave it there if we cannot simplify this. But I think this can be simplified because let's see, divide by 512. Yeah, but I think we can simplify this. So if we can simplify this, we can simplify that. And that's how you find the sum. Okay, so just go through and try to simplify by yourself. Then I am going to ask you to the same question, you write it down. So write this down, the same question, but instead of seventh term, you're going to find the 17th term. Okay, and here instead of the first nine terms, you're going to find the first 19 terms. So the same question, then you're asked to find the 17th term, then the sum of the 19th term. Then I'll ask you to submit this question just now. All right, so I'll be waiting for your feedback. Any questions, you can reach out in my inbox.